Physical quantities are properties that can be measured, like length, mass, time, and temperature. Measurement determines the size or amount of these quantities using specific tools and units. In Class 8 Physics, students explore these fundamental ideas. Different physical quantities are measured using different units, like meters for length and kilograms for mass. Mastering these basics helps students perform experiments and solve physics problems effectively. Accurate measurements are crucial in fields like engineering, medicine, and everyday problem solving. Physics involves practical applications, not just theory. A solid grasp of these concepts is essential for all students. Mass is the amount of matter in an object, measured in kilograms. Volume is the space an object occupies, measured in cubic meters or liters. Density combines mass and volume, defined as mass per unit volume. The formula for density is density equals mass divided by volume. High-density materials like lead have a lot of mass in a small volume, while low-density materials like feathers have less mass. Understanding these concepts explains why objects sink or float. In daily life, knowing about mass, volume, and density helps in tasks like cooking, measuring fuel, or packing. These concepts are fundamental for various practical applications. They help explain the behavior of objects in different environments. The formula for mass is mass equals density times volume. For example, if density is 5 kilograms per cubic meter and volume is 2 cubic meters, the mass is 10 kilograms. Volume equals mass divided by density. If mass is 10 kilograms and density is 2 kilograms per cubic meter, volume is 5 cubic meters. Density equals mass divided by volume. If mass is 20 kilograms and volume is 4 cubic meters, density is 5 kilograms per cubic meter. These formulae are essential tools in physics. A spring balance measures the weight of an object based on Hooke's law. It consists of a spring attached to a hook and a scale. When an object is hung from the hook, the spring stretches, and the scale measures the weight. The spring balance converts this weight into a force measurement, usually in newtons or grams. Using a spring balance is simple. Calibrate it, hang the object, and read the measurement. This tool is useful for measuring small weights in laboratories and everyday situations like weighing produce in grocery stores. Understanding how a spring balance works helps appreciate the principles of force and elasticity. It's a practical tool for various applications. Relative density, or specific gravity, is the ratio of a substance's density to the density of a reference substance, usually water. It is a dimensionless quantity. The formula is relative density equals density of substance divided by density of water. For example, if a substance has a density of 8 grams per cubic centimeter and water has a density of 1 gram per cubic centimeter, the relative density is 8. This means the substance is 8 times denser than water. Relative density helps determine whether an object will float or sink in water. This calculation is useful in scientific and industrial applications, like determining purity or buoyancy. Understanding relative density is crucial for experiments involving buoyancy and flotation. The International System of Units, or SI, is the standard measurement system worldwide. It ensures consistency and accuracy in measuring physical quantities. Basic SI units include meters for length, kilograms for mass, and seconds for time. Using SI units allows scientists and engineers globally to share and compare data accurately. In physics, SI units simplify calculations and reduce errors. For students, learning to use SI units correctly is essential for solving problems and conducting experiments. Adopting SI units in daily life ensures consistency and helps avoid misunderstandings. It's a critical part of scientific literacy. Buoyant force is the upward force exerted by a fluid on an object immersed in it. Archimedes' principle states that the buoyant force equals the weight of the fluid displaced. An object floats if the buoyant force equals its weight. A ship floats because its weight is balanced by the buoyant force. This explains floating icebergs and boats. The concepts of physical quantities and measurement are foundational in physics and essential for understanding the world. From measuring ingredients to weighing luggage, these principles are part of our daily lives. Tools like spring balances make tasks easier and more accurate. SI units provide a universal standard for measurements. This consistency is vital for scientific research and trade.